Hello class, welcome back. Today we're going to cover, I actually forget what we're covering today. Give me just a sec. Oh, great. This is that episode. Okay, here we go. We're going to talk about mixed numbers and why, even though I don't particularly like them that much, that doesn't mean that I get to slack off and not teach you about them because, like all numbers, they do have their uses. So, let's start out with some of the positives of mixed numbers. Okay, mixed numbers are numbers like 1 and 1/2. Okay? Numbers that include a whole number component and a fraction component. That is a mixed number. Or like if I say I'm going to take a vacation for the next 2.5 weeks, or something like that. And that is one of the pros of mixed numbers. They are very easy to communicate. Everybody knows if I say 15.5, that is 15 and then half of 1 again, right? Somewhere exactly in the middle of 15 and 16. But if I say 15.75, well, now you have to at least know a couple of things about the decimal system in order to understand what's going on. But these mixed numbers do make a lot of intuitive sense to us. When I say 1.5, it's pretty easy to see that I mean halfway between 1 and 2. Unfortunately, that's kind of where the usefulness ends. On the con side, the introduction of mixed numbers into ordinary arithmetic can make it very much more complicated. And the reason for that is that each one of these mixed numbers right here is actually kind of a miniature arithmetic problem in itself. When I say 1.5, what I'm really saying is 1 plus 1/2. And in order to be able to do good arithmetic to it, we're going to have to combine that into a fraction so that we can use what we learned in the previous videos. And I'm not just talking about on a math problem. I'm talking about in regular, ordinary, real life. For example, this 1.5 could represent 1.5, let's say, cups of flour. I do enjoy baking very much, so this is relevant to my life. Now, as you see here, I have a 1 cup, this is a measuring cup that measures 1 cup, and I have this half cup here, right? So if I filled each of these with flour, then that's enough for my recipe. But I don't normally do that. Why would I want to dirty 2 dishes when I can just take this half cup here and use it 3 times, right? 2 of these equals 1 of these. So why would I bother with this larger one at all? I'm just going to take this smaller one and fill it up 3 times for my recipe. So instead of 1 and 1/2, I prefer 3/2. I definitely prefer fractions over mixed numbers because fractions, even though I know they can make people break out into sweat, they are a lot simpler to work with because they are at least just one division problem, right? Whereas this mixed number up here is an addition problem and then a division problem, or a division problem inside of an addition problem. This is why I'm not a big fan of mixed numbers in a mathematical sense. So essentially, anytime you see a mixed number, you are going to turn it into a fraction, and then you can do whatever math you need to do to it. So let's take a look at some examples. These are problems that I skipped in previous videos because I wanted to save all of the mixed number problems for one video. So I'm going to go ahead and get off the screen so that we have all the space that we need in order to give these problems a try. So we're starting with number 7 here, and as you can see we have -2 and 1/5, which I will put in parentheses, times -1 and 3/4. So our job, first and foremost, is to take these two and turn them into fractions, all right? And this is something that we're going to do several times, so I'm going to break it down piece by piece the first time we do this, and then I will discuss shortcuts as we go, okay? So let's start with this -2 and 1/5. So what that is -2 plus 1/5. Essentially, it is a small fractions problem. And we've done enough videos on this by now that you should know that this -2 goes over 1, and then we need to find that common bottom number, which we can do in a couple of ways. We can just visualize 2 cakes being cut into 5 pieces, or we can multiply the top and the bottom by the denominator of the other fraction. Okay, this should be review. We're actually multiplying by 5 over 5, which is just 1. We're allowed to multiply by 1. So we end up with -10 over 5. That's the same thing as -2. We haven't changed anything. Ooh, I almost made a very big mistake here, and I've been making this mistake for days now. Let's take a closer look at my work here, because this is important. When I say that -2 and 1/5 is -2 plus 1/5, here, I'm going to erase this so that we can see it more closely. Okay? When I say that it is -2 plus 1/5, I actually got the negative in the wrong spot. Okay, do you see how the negative is right here just in front of the 2? That is incorrect because that negative also applies to the 1/5, right? If I was looking at a number line, here's -2. -2 and 1/5 would be further down the number line than -2. So that negative has to apply to both. It does not belong inside the parentheses with the 2. Where it belongs is outside the parentheses. So that negative is going to apply to this entire amount and not just the 2. So, where was I? -10 over 5 and -1 over 5. Okay? The negative applies to both the 2 and the 1/5. So, since I already have a handy number line right here, let's say I start at -10, and then I am going down 1. Right? I already know my answer is going to be over 5 because I am dealing in fifths. That is essentially my unit. So if I start at -10, and then I go down 1, I'm at -11. The answer is -11 over 5. Okay? So that -2 and 1/5, we are changing it to -11 over 5. Now, for the second one, I want to show you a quick shortcut, okay? Again, remembering that we are going to deal with the negative afterwards, you don't have to list out all this work every single time. Like I said, I just wanted to break it down all the way the first time. Okay, so for this second fraction, what we're going to do, we have this -1 3/4. So some of you probably learned in elementary school or in middle school that what you do when you are changing a mixed number into a fraction is you take this whole number, you multiply it times the bottom number, which is the denominator, right? So that would be 1 times 4, which is 4. And then you add that result to the number that's on top, the numerator. So you would add 3. So this essentially gets us negative, don't forget that negative, we can't forget it. Well, let's see, 4 plus 3 is 7 over 4. Now, it's easy to see which one of these two methods takes more work. But I think it's important that we look at these two techniques and see that they're actually the same, okay? When you take this 1 times 4 over here, that's the same thing as how we got this -10, right? We took -2 times 5. It's the same exact principle. And then in the next step, we added them together right there. Or subtracted because one was negative, but remember addition and subtraction are essentially the same thing. So these two methods are both the same method. It's just that one of them is much more spread out because I wanted you to see the ideas involved. The other one is more compact. It is a shortcut. All right? Not that there's necessarily anything wrong with shortcuts, you just have to make sure you understand the idea as well. And that shortcut is to multiply the whole number by the bottom number and add that product to the top. So that is the technique I will be using going forward from here, but please don't forget where this shortcut came from. Okay? So back to the problem. We have -11 over 5 times -7 over 4. Now, some of you might be asking me, wait a second, Mr. Cunningham, why are you putting the negative numbers up top when in the original problem they are out in front? And I answered that question in a previous video, which I will be linking right now if I'm not lazy. And the short answer is it doesn't matter where they go. I default to putting them on top because I like to have a default position for them. So for me, I always put them on top. But so long as you stay consistent, you'll be fine. Either way, we now have a case of multiplying straight across the top, multiplying straight across the bottom. -11 times -7 is +77. 5 times 4 is 20. And that is finally our final answer. I hope you can see why I dislike these kinds of numbers so. But it is good practice with your fractions, so let's go ahead and do another one of these. So here we have number 8, and it doesn't look too bad. We have -1 1/4 times 9, which again, we should automatically be saying is 9 over 1. So this time we only have one mixed number to translate, to transform. So let's go ahead and do that. We start by taking that 1 and multiplying it by the denominator 4, which gives us 4. And then we add that to the numerator, which gives us a final answer for this particular mixed number of -5 over 4. So as a quick recap, the reason why this shortcut works is because what we're essentially doing is we're doing -1 plus 1/4, right? And we're recognizing that 1 is the same thing as 4 over 4. We're using a shortcut to do it, but that doesn't change the fact that what we're doing is valid, okay? So we have -5 over 4 times 9 over 1. Once again, straight across the top, -5 times 9 is -45. Straight across the bottom, 4 times 1 is 4. Our answer is -45 over 4. So far, so good. Let's keep going. Number 19. Ooh, we're dividing now. So remember, don't be afraid, when we're dividing, we're just going to end up flipping whatever this fraction is, we're going to end up flipping it over and multiplying instead. So, no worries there. One times 7 is 7. 7 plus 6 is 13 over 7. See, this gets faster as you get better at it. Divided by, we'll flip it over in a minute. 5 times 4 is 20, plus 3, so we have 23 over 4. So 1 and 6/7 is the same thing as 13 over 7. 5 and 3/4 is the same thing as 23 over 4. So what we're doing is 13 over 7 times 4 over 23. I am going to attempt to do this in my head, and I'm not going to check my work. 13 times 4 is 52. Let's see, 7 times 20 is 140. 7 times 3 is 21. So 161, I want to say, is the correct answer. 52 over 161 is our final answer. If I got it wrong, let me know in the comments. In fact, anytime I'm doing problems, I sometimes make mistakes that slip through the editing process. If you give me a comment that calls me out on my error, I will pin it to the top of the comments board unless there's already one up there that says it already. You know what I mean. Okay, so our next problem is -3 and 7/10 divided by 2 and 1/4. Let's get started. So remember with the negative that we're going to apply this at the end. Okay, we're not going to mess around with that negative until after we're done converting this mixed number into a fraction. When I first went to record this, I made the mistake several times of not distributing this negative the way it ought to be to both the 3 and the 7/10, and it caused me to have to go back and re-record some stuff. So making mistakes is fine. The fact that I made that mistake is why I am able to point it out to you now. So once again, we're going to start with 3 times 10, and that gives us 30. And we're going to add that to the top number, and we get 37 over 10, and now we apply the negative. Although, like I said, I normally prefer to put the negative on the top number, but that's just my own personal preference. Divided by. We have 2 times 4 is 8, plus 1, 9 over 4. Okay, once again, same deal, -37 over 10. Instead of dividing by 9/4, we will multiply by the reciprocal, which is 4 over 9. Straight across the top, let's see, 30 times 4 is 120. 7 times 4 is 28, so I think this is 148, negative 148, over 10 times 9 is 90. I notice that both the top and the bottom of this fraction are even, so I'm going to divide them each by 2 in order to reduce the fraction. As a sidebar, remember that dividing by 2 is the same thing as multiplying by 1/2, and if I multiply the top and the bottom of the fraction by 1/2, I'm not actually changing the value of the fraction, I'm multiplying by 1. Okay, so I get -74 on the top, and I get 45 on the bottom, and I do believe that is our final answer, -74 over 45. So that's 19 and 20, which were about dividing mixed numbers. Again, dealing with these mixed numbers is really no different than dealing with fractions. It's just a little miniature addition problem within the greater problem. We have 2 more examples. One is addition, one is subtraction. Let's knock them out. Number 23 says -1 and 7/8. So we'll go ahead and do 1 times 8, which is 8. plus 7. We get 15 over 8 for our first fraction. As for the second one, 3 times 2 is 6. Plus 1 is 7 over 2. And both of these are negative. Well, this is a nice, good example right here of one time when you have unlike bottom numbers, but you don't necessarily want to go multiplying them together. You notice that 8 is divisible by 2. 8 is a multiple of 2. So I'm going to multiply by 4 over 4 because I want my two denominators to be the same. So let's see, I get negative 15 over 8 plus negative 28 over 8. Negative 15 minus 28, they are the same sign, they are both negative, so we are pointing downward and adding the values of the number. So 15 plus 28 is 43, I want to say. So this should be negative 43 over 8. And that's our answer. All right, last problem of the video. Let's give it a shot. Negative 2 and 5/6 minus negative 1 and 1/4. Man, we sure saved the best for last. Let's go ahead and do 2 times 6, which is 12, plus 5. Negative 2 and 5/6 is the same thing as negative 17 over 6. Minus, I will put this in parentheses to make sure that we know that the negative applies to everything. 1 times 4 is 4, plus 1 is 5, so this is negative 5 over 4. Now, as I know a lot of you will, I'm just going to go ahead and cancel out those negatives, so to speak, just recognizing that a negative times a negative is a positive, as we said multiple times several videos ago. And now, this is one of those times when I think it is best to just look at the two denominators and go, meh, I'm not interested in finding the lowest common denominator. I'm just going to multiply them by each other, okay? This green denominator is 6, so I'm going to multiply the other fraction by 6 over 6. This black fraction here has a 4 denominator, so I'm going to multiply the other fraction by 4 over 4. Quick, easy, guarantees me a common denominator. Okay? Yes, your teacher may have taught you to then divide by the GCF and get 12 as the lowest common denominator, and that is a valid way of going about this. I just don't feel like that amount of work is necessary for this problem. So, 4 times negative 17 is negative, negative 40. And then 7 times 4 is 28, so negative 68 over 24. Let's move this up a little bit. Plus 5 times 6 is 30 over 24. If I have negative 68 and I'm going up 30, let's use the rule that I showed in one of our very first videos. If you have two opposite, we know it's going to be over 24, and we have negative 68 plus 30. So we have two opposite signs, right? A negative and a positive. So what do? We take the bigger one and use its sign. So 68 is the quote-unquote larger number. It is farther away from 0. And then subtract the two. 68 minus 30 Well, 60 minus 30 is 30, so we get negative 38 over 24. Once again, noticing that both of them are even, so divisible by 2. Negative 38 divided by 2 is negative 19 over 12, which is our final answer. So that's our video on mixed numbers. When it comes right down to it, love them or hate them, they are something that you will have to be fluent with because they do come up not only in math problems, but also in our day-to-day lives. I hope you'll come back next time. I promise that I will be wrapping up this review course that has already gone on way longer than I expected it to, but it will be wrapped up within the next 2 or 3 videos, and then we will actually move on to Mathematics 1 content. Until then, thank you for sticking with me for this long, thank you for watching the video, and I'll see you next time.